Okay, so let's talk about comparing numbers that are in scientific notation and what happens if a number is almost in scientific notation, but not quite. So we're going to call this number at the front of the scientific notation piece the coefficient. Just for our purposes today, there are other terms that people use for it, but for eighth grade math, it's fine for us to refer to it as the coefficient. So this first number I know represents a really large number because it has this positive 8 as an exponent. That means that I'm multiplying this number times 10 8 times. So 10 times 10 times 10 times 10 times 10, right? 8 tens multiplied by each other times that coefficient number underlined in blue. So in math, we have a trick, and I am not a fan at all of saying move the decimal because mathematically speaking, you can't move the decimal place because it is a fixed place in our number system. It is the place that exists between the ones place and the tenths place, but that's not going to help you guys remember how to do this. So I'm going to say or be okay with us talking about moving the decimal or counting decimal spaces, but mathematically it's not accurate and I'm just going to get over it and it's fine. It's just one of those nerdy teacher things that I have to at least say that I know it's not correct to talk about it like this. So if I am multiplying by 10, what actually happens is the digits are going to shift a place value every time I multiply or divide by 10. Our whole number system is based on 10. So when I am multiplying by 10, the number is getting larger. This is why this decimal moving trick works. So if I move the decimal point and my arrow didn't work, one space, I now have 78.3, which is 10 times larger than 7.83. If I move it again, then I have 783, and so on and so forth. So if I had done that, that would have just been 10 to the second power. This would have been 7.83 times 10 to the second power. So I need to keep going. So we use these little bumps underneath the number to help us like count the spaces that we are shifting, okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8. Probably not a great choice on my part to choose 8, but here we are. So this is where my decimal point is going to end up. All of these other spaces, I like to say I don't want to say we're adding zeros because if you add 0 to something, you haven't added anything. I like to call these placeholders because they are holding the place of our place values. Think back to place value chart from like fourth grade. So then I can throw in my commas to know that this is 783 million is actually this number that I'm dealing with here. So this is a really large number that we can use scientific notation to write as a smaller number. Over here, let's look at the second number. This is representing a really, really small number. And I know this because, well, not really small, relatively small, because we have a negative exponent. That means I'm going to be multiplying by the base's reciprocal. In this case, the base's reciprocal is 1/10. And for our purposes, we're going to think of multiplying by 1/10 as the same thing as dividing by 10. So I'm dividing by 10 multiple times in this scenario. Anytime I divide something by 10, that number is going to get smaller. So in this situation, my decimal trick still works, but we're going to be moving the opposite direction because I want the number to get smaller. If I was to divide by 10 once, the decimal would now be here, giving me 783 thousandths. I don't even think I said that correctly. If I said this wrong, don't hate me. That's not my expertise. That's like a third grade standard. 0.783. It's late. If I was going to move the decimal another space, right, that would be here. And I would have to add that place value in. So far I've moved 1, 2 spaces. If I'm moving another space, okay, now the decimal is out here. I have to have 2 placeholders. And the final answer would be this. So a pretty small number that most of us on a day-to-day basis are not going to have to come into contact with a number this small. If you're a scientist out in a lab somewhere and you're dealing with amoebas, you probably have to deal with numbers way smaller than this. So this is the standard form version. This is a standard form version of this scientific notation number. Hopefully you're understanding the difference between positive exponents and negative exponents when we're dealing with scientific notation. It helps us express really, really large and really, really small numbers.